Hello, Professor. My name is Yashaswini Reddy Kadpalli, and today I'm excited to present my project title, Movie Recommendation System using Content-Based and Collaborative Filtering. Over the next few minutes, I'll walk you through the problem statement, approach, implementation, and outcomes of the project. With the overwhelming number of movies available today, users often struggle to decide what to watch. Recommender system helps solve this by suggesting movies based on a user's preferences. This project is defined to intelligently guide users towards films they are likely to enjoy. I will be covering the problem, objectives, and methodology, system design, and some key results that demonstrate the effectiveness of our hybrid recommendation engine. The entertainment industry has grown rapidly, and users now have access to thousands of movie titles at their fingertips. However, traditional recommendation models often lack personalization and cannot adapt to user behavior dynamically. The challenge is to move beyond generic suggestions and deliver customized recommendations. To tackle this, I have developed a hybrid system combining both content based and collaborative filtering, aiming to recommend movies that users are more likely to enjoy based on their history and preferences. The goal of this project was to create a recommendation system that could deliver personalized movie suggestions with a high level of accuracy. The system was then designed to incorporate both user based and item based collaborative filtering as well as content based filtering to provide robust recommendations. Another key aim was to offer a clean and accessible user interface that would allow users to interact with the system, and ultimately the objective was to bridge the gap between user expectations and system recommendations, improving user satisfaction and engagement. So I began by collecting and pre-processing the movie lens dataset, which contains over 100,000 ratings for 9,000 movies by 600 users. I have enriched the data using metadata such as genre, cast, and keywords from TMDB. Using this information, we applied TF, IDF, and count vectorizer techniques to convert text into numerical vectors for content based filtering. Cosine similarity was then used to measure how similar movies are. On the collaborative side, I used K nearest neighbors and user interactive interaction matrices to predict what users with similar taste might like. Coming to the system design, so the system follows a modular architecture. It starts with data collection from both the movie lens and TMDB APIs. This raw data is then cleaned and processed to extract meaningful features such as genre, vectors, and keyword tags. This processed features feed into the recommendation engine, which consists of both content based and collaborative modules. The content based engine uses vectorized movie attributes, while the collaborative engine uses rating history across users and items. On the front end, Streamlit services serves as the user interface, enabling users to input a movie title and receive a dynamic recommendations instantly. And then coming to the key features, the system features three core recommendation engines. One is content-based filtering, user-based collaborative filtering, and the item-based collaborative filtering. The content-based engine matches movies based on their metadata, such as genre and cast. The user-based model finds users with similar rating patterns and recommends movies liked by those users. The item-based model suggests movie similar to the one a user has already rated highly. Together, they form a hybrid system that increases accuracy and diversity in recommendations. A simple interactive Streamlit interface ties everything together and makes the experience seamless for end users. Then the project was implemented using Python and libraries such as Pandas, NumPy, Scikit, Learn, NLTK, and Streamlit. We used TF-IDF and counter vectorizer to extract text-based features and cosine similarity to calculate closeness between movies. For collaborative filtering, we implemented both user-based and item-based KNN models. We also tested similarity metrics like Pearson, correlation, and cosine distance to see which performed better under sparse data conditions. All models were integrated into a lightweight Streamlit app that allows user to get recommendations in real time. So coming to the results, the recommendation system was able to successfully generate personalized movie suggestions. For example, if the user selects the metrics, the system recommends movies such as Inception and The Prestige, which aligns well in terms of theme and audience interest. Similarly, Gladiator produced results like Star Wars, The Return of JD, and also the Pirates of the Caribbean, mostly like that. So visuals like bar graphs showed the top 10 closest matches and based on similarity scores, making it easy to interpret. The streamline UI displayed both lists and plots, giving users a clear and interactive experience. For testing and evaluation, the system was tested with a range of inputs and user profiles. Evaluation metrics such as precision and recall were used to access how well the model could return relevant results. The performance was consistent across the different types of users, indicating that both the collaborative and content based parts of the system were working well. Graphs tracking precision and recall showed that the system maintained high scores, which means it was recommending not only relevant movies but also not missing many good ones. So, for conclusion, this hybrid movie recommend system combines the best of content based and collaborative filtering to deliver meaningful personalized results. The integration of TMDB metadata and the movie lens dataset proved to be effective in capturing both items and user similarities. The system demonstrates how data science and machine learning can be applied to real world entertainment applications to improve user engagement and satisfaction. So, for future work, moving forward, I plan to enhance the system by allowing users to log in and track their preferences over time. Real time feedback mechanisms such as like or dislike buttons could be used to continually refine the recommendation engine. Another area of expansion is integrating APIs like IMDb and Netflix to fetch real time data and include more metadata features as well. There's also scope to recommend TV shows and web series, making the platform more comprehensive and adaptive. And this is it, Professor. Thank you for the support throughout this project. Thank you.